Hi everyone, today we learn how to find the trisectional points of a line segment. So let's do this step by step. So let's take a line segment, say AB, of length L, and let's take a point M right in the middle of it, such that this is the midpoint. And since it is the midpoint, it will divide the line segment in two equal parts, and this is L by 2 and this is L by 2. And when this happens, we call this M as the bisection point, because it cuts in two equal parts. Now this gives us an idea what trisectional points might be, because trisectional points are simply points that divide the line segment into three equal parts. From this it is clearly seen that one point is not enough to do that. We need at least 2 points. So let's take these 2 points and we can see now the line segment is perfectly split into three equal parts. So let's call these points P and Q, and then you can see this length is L by 3, this length is L by 3, and this length is also L by 3. So one thing we've established is that we need 2 points to divide the line segment into three equal parts. Now let's focus more on this and see if we can get more information out of this. So let's try to see the ratio. So let's try to see the ratio AP divided by PB. At which ratio is the point P cutting the line segment at? So AP by PB, so AP length we know is L by 3 divided by PB length would be L by 3 plus L by 3, so it becomes 2L by 3. And now L by 3 into 2 is 2L by 3, so this becomes 1 here, this becomes 2 here. So this is equal to 1 divided by 2. So P, this point, divides the line segment in the ratio 1:2. So we can write here that P divides the line segment AB in the ratio 1:2. Now let's do the same for Q. Let's see if there's any peculiar ratio that Q also divides the line segment up. So we have AQ here, AQ divided by QB. So AQ is L by 3 plus L by 3, so that becomes 2L by 3 divided by QB is L by 3. And L by 3 into 2 is 2L by 3, so this becomes 1, this becomes 2. So we have 2 divided by 1. So now Q here does the exact opposite. It divides the line segment in the ratio 2:1. So we can write this as Q divides the line segment AB in the ratio 2:1. Now these are really important pointers that we need to keep in our head, because this would really help us in questions. Let's see how. Let's see a question. So say a question is given, find the coordinates of the points of trisection of the line segment joining the points A 1, 1 and B 4, 7. So let's take our graph paper out. So we have our graph, this is our x-axis, this is our y-axis, and let's plot these points A 1, 1, so that is 1, 1, so that is here, A 1, 1, and B 4, 7, so that is 4 here and 7 here, so that's B 4, 7. Now let's connect these 2 points to form the line segment. And now we need to find the coordinates of the points of trisection. So let's see, we have 2 points of trisection. Let's say that they are here, say P, and here, say Q. So whenever a question like this is given, let's see what our approach can be. Now understand, we know the coordinates A and B. From the previous slide, we also know the ratio in which P cuts this line segment. So when a ratio is known, the 2 points are known, it really gives us all the information that is needed to apply the section formula. So let's try doing that. So we have section formula as P x, y is equal to M x2 plus N x1 divided by M plus N, M y2 plus N y1 divided by M plus N. So here what are M and N? So if P divides this line segment in the ratio 1 and 2, then we can write that AP divided by PB is equal to 1 by 2, and we can write this equal to M by N, which is the internal ratio in which P divides the line segment AB. So our M becomes 1 and our M becomes 2. And what is our x1, x2 and y1, y2? So let's take this as our x1, y1 and this as our x2, y2. So our x1, y1 becomes 1, 1 and our x2, y2 becomes 4, 7. So now we have all the values x1, y1, x2, y2 and m and n. So all we need to do to find the coordinates of P is to apply this formula. So we have P xy is equal to mx2 plus nx1 divided by m plus n, comma, my2 plus ny1 divided by m plus n. And now all we need to do is plug in the values. So here m is 1, so we have 1 here. x2 is 4, so we have 4 here. n is 2, so we have 2 here. And x1 is 1, so we have 1 here. And m plus n becomes 2 plus 1, so that becomes 1 plus 2. Here again m is 1, y2 is 7, n is 2, and y1 is 1, and m plus n is 1 plus 2. So now we need to do the calculation. So 1 into 4 plus 2, this becomes 6, and 1 plus 2 is 3. So this becomes 6, and this is 3. 7 plus 2, that becomes 9. 1 plus 2 is 3. So now 3 into 2 is 6. So this becomes 2, and 3 into 3 is 9. So this is 3. So from this calculation, we get the point P as 2, 3. And that's really all about it. From section formula, we could easily calculate the coordinates of one point of trisection. So let's write this point here and let's plug it here. And now let's try to calculate the other point Q by the same formula. But here Q divides the line segment AB in the ratio 2:1. So here the ratio would be AQ divided by QB is equal to 2 by n. So my M divided by n would be, M here would be 2 and n here would be 1. And now let's apply the same formula, section formula. Here x1, y1 is 1, 1 and x2, y2 would be equal to 4, 7 only. Same as the last one. So now our formula is qxy is equal to mx2 plus nx1 divided by m plus n, my2 plus ny1 divided by m plus n. So let's plug in the values. Here m is 2, n is 1. So m becomes 2, x2 is 4, n becomes 1, x1 is 1, and m plus n becomes again 2 plus 1. On the y coordinate, we have m as 2, y2 as 7, n as 1, y1 as 1, and we have m plus n as 2 plus 1. So now let's calculate it. 2 into 4 is 8, 8 plus 1 is 9, so this is 9. 2 plus 1 is 3, 7 into 2 is 14, plus 1 is 15, so that's 15, and 2 plus 1 is 3. So this becomes 3 into 3 is 9, and this becomes 3 into 5 is 15. So our point becomes 3, 5. So this here, point here is 3, 5. So the points of trisection that we got are P 2, 3 and Q 3, 5. So that's all about it. That's how you calculate the points of trisection. Thank you.